Hello and welcome to the video abstract of our paper Improved High Precision GNSS Navigation with a Passive Hydrogen Maser, where we will give you a brief overview of our work and discuss our main findings. In signal receiver positioning, we always need to synchronize the timescales of our receiver and the satellites in use. Typically, this is done by introducing so-called clock errors for each satellite and the receiver into the estimation process. The satellite-specific corrections can be either extracted from the broadcast navigation message or derived from IGS products. On the receiver side, the clock error has to be corrected by the user. We must do this on an epoch-wise basis because of the low accuracy and stability of the built-in quartz oscillator. In addition, estimating the clock error together with the receiver coordinates introduces high parameter correlations and decreases the height accuracy. One possibility to overcome these drawbacks is to replace the internal oscillator by a more stable external one and adapt the estimator in data analysis accordingly. We refer to this approach as receiver clock modeling. This method, although, is only physically meaningful if the noise of the observation type in use is smaller than the oscillator noise. That means in case of PPP, we need a very stable atomic clock like a passive hydrogen maser. On the other side, receiver clock modeling with code observations is already feasible with a smaller oscillator like a chip-scale atomic clock. Overall, this approach is especially beneficial in kinematic GNSS applications, as it was already shown by our group and others in the past. As a proof of concept experiment, we carried out a test drive in the city of Hanover, Germany for about 80 minutes. In order to be able to investigate the impact of such a passive hydrogen maser in a kinematic application, we drove with different dynamics in various environmental situations. Inside the vehicle, we used two geodetic Java delta receivers, one driven by its internal quartz oscillator and one connected to the maser, as well as a Novatel span system with a tactical grade IMU. Also, a local reference station recorded GNSS data during the experiment. We computed a precise reference solution based on GNSS and IMU data in a tightly coupled approach. The kinematic PPP algorithm with clock modeling was implemented by means of a linearized Kalman filter in our in-house MATLAB-based GNSS software. The actual clock modeling is realized through the clock process noise of the filter. For that, we applied the maser-specific spectral coefficients to the model as proposed by Van Dierendonck in 1984. In all analysis, we used 10 Hz multi-GNSS observation data in IGS, MGEX, satellite orbit, and clock products. As a result, the PPP solution with clock modeling exhibits smaller position and velocity deviations from the reference solution than the solution without clock modeling. Numerically speaking, we achieve an improved precision and accuracy of the position and velocity states of 15 and 57% respectively. Also, the reliability of those states is enhanced by about 30%, as shown in the figure, where the results with clock modeling are depicted in black and those without in gray. The biggest benefit from receiver clock modeling comes to light in situations with sparse observation data, like in this example where the car drove through an underpass from west to east and in the process stayed beneath it for about 30 seconds. Without clock modeling, we see stronger position deviations in all three components and more pronounced scatterings of the velocity deviations, especially in the up component. The reason for this are the clock states, where in the case of clock modeling, the estimates do not deviate from the nominal behavior of the maser as much as they do when no clock modeling is applied. Thanks to these physically more meaningful clock states, the position deviations are not only significantly reduced, but also the drifts in the east and up coordinates are prevented. If we have piqued your interest, you can find more details and further investigations in the full paper. In case of any questions, please don't hesitate to contact us. Until then, thanks for watching and goodbye.